This video's purpose is to teach you about the net force as mentioned in Newton's first law. The purpose of the net force is to determine the effect the forces on an object has on the motion of the object. The net force is the resultant created by combining all the forces acting on an object. Quite simply, this means that once you've combined all the forces, the result, or the resultant, is what we will have for our net force. I have here an object. We're going to use a standard everyday box. It has three different forces acting on it, all of them in the x coordinate direction. We have the 6 Newton force to the right, a 4 Newton force to the left, and a 5 Newton force to the left. To find the net force, we need to combine all of them. There are two methods we're going to discuss on how to do this, a graphical method and an algebraic method. The graphical method uses the fact that a force is represented by a vector. The vector, remember, has a magnitude, that is the size, in this case a 6 Newton magnitude, and a direction, in this case it is headed to the right. So graphically, if we wanted to find this answer, we could draw to scale, and I am simply going to approximate, but if we used a ruler and very carefully measured out perhaps 6 centimeters, where every centimeter is a Newton, we could actually use this to determine very accurately the resulting answer. So this is my 6 Newton force to the right. To add a vector, I use the tip to tail method. So the tip of this vector is added to the, we go to the tail of the next one. The next vector was a 4 Newton force to the left. And then I had on the tip of that one, I do the next one, which was a 5 Newton force, again, to the left. My resultant is basically what would happen if I went from the very beginning, the very first tail of the vector, to the tip of the very last one. This is my resultant. In this case, it is going to be, if you were to do the geometry on this one, 6 forward, 4 back, and another 5 back would give it a length of 3 newtons. In this case, algebraically might be a little bit more straightforward. So we are going to simply do the same thing here. I have a 6 Newton force combined with a 4 Newton force combined with a 5 Newton force, and this will give me my net force. Now, this is to the right, so it's positive. My 4 newtons is to the left, which I'm going to assign as negative, and the 5 newtons is to the left, which is going to be a negative. So this turns into, I'm going to drop the units here for clarity, 6 minus 4 minus 5 equals my net force, or negative 3 equals my net force. Let's put the units back in. I get the same answer. The negative tells me it's going to the left, and the 3 agrees with what my resultant was on the other one. So this can be summarized into a very simple formula. Net force can be rewritten as the sum of all the forces acting on an object. So the sum of all the forces is simply first force plus the second force plus the third force, and so on until you have put all the forces together. The positives or negatives comes in with if this force is to the right or the left, up or down. It's assigned when you actually put a value to the forces. This becomes a little trickier when we have 2 dimensions. I'm again going to show you a graphical approach and an algebraic approach. In the graphical approach, we're going to do tip to tail. So I'm going to start with the 6 Newton force, just like last time, to the right. To the tip of that one, I'm going to add the tail of the 4 Newton force going down. I'm then just going to tack on the 2 Newton force to the left. And then I'm going to do an 8 Newton force. Now that's going to take me all the way up here. It's going to do quite a bit here. Like that. Now you can do this in any order you want, and you will still get the same answer. The answer goes from the very beginning of the entire sequence to the very end of the entire sequence. Or in this case, I am going to get a vector up and to the right this way. Now this graphical approach is a little harder to tell exactly how long this resultant is going to be. So this one is definitely going to be a bit easier to do algebraically. You can figure this one out by doing the legs and Pythagorean's theorems and being a little bit more careful. I generally prefer the algebraic approach with 2 dimensions. Again, we have the sum of my forces is equal to my net force. Now this time things are a little tricky because I cannot just add 6 to the right plus 8 up. So just as with our motion in 2 dimensions, we are going to split this. And you do this anytime you have 2 coordinate axes. Sum of the forces in the x, sum of the forces in the y. So let's do the x direction ones here real quick. Sum of the forces in the x is equal to 6 newtons minus 2 newtons. Or sum of the forces in the x is going to equal 4 newtons. It's positive, so it's going to be to the right. And in the y direction, we're going to do the same thing. Sum of the forces in the y direction. This time it is 8 up and 4 down, so minus 4. If you're ever wondering about signs, remember, you can assign them at the beginning. Tradition is positive for up and positive to the right. Do not have to follow that. What's really important here is that 8 is going the opposite direction of 4, so whatever signs I choose, these have to be opposite signs. So sum of the forces in the y direction comes out to be a simple positive 4 newtons. So I'm going to push this way 4 newtons, and I'm going to push this way 4 newtons. I am going to combine these graphically real quick so we can see what's going on. That's this way 4 and that way 4. My resultant is going to go this way. And you can see from this that we should be able to come up with this side here using Pythagorean's theorem. So we can recombine these to get the actual net force using Pythagorean's theorem, a squared plus b squared equals c squared. So 4 squared plus 4 squared equals c squared. That is 16 plus 16 equals c squared. 32 equals c squared. And I don't remember my roots very well. Or 5.6 equals c. So I have a 5.6 Newton force up and to the right. I should also, to be complete, find this angle. So I would just use sine, cosine, or tangent to figure this guy out to get your angle. We'll leave that for another exercise. The last problem I have is what happens if you have an angled force and you need to figure out what's going on. Again, we treat an angled vector the same way we did in 2-dimensional motion. So I'm going to do it graphically real quick. The reason I like to do graphically is I can kind of estimate how this is going to look. So I have 12 newtons up this way. So if it's about that long, about half that is going to be my 6 newtons. So maybe something down like this is 6 newtons. So my resultant is going to be to the right. It's a little hard to tell what this is going to be graphically unless I very carefully measured out the angles with a protractor, did it to scale with a ruler, in which case I could simply measure the length and the angle directly. But my answer is going to point to the right. So to do this algebraically, we're going to take the sum of the forces. We're going to split it again into the forces in the x direction and the forces in the y direction. So the sum of the forces in the x direction is going to equal, now this is tricky, I don't have an x direction, so I need to find that. I'm going to break this down into a force in the x and into a force in the y. Off to the side, I'm going to do the trigonometry for that. That is going to be 12 cosine of 30 will get me fx, and 12 sine of 30 will get me fy. Doing that math real quick. 12 cosine of 30 gets me an answer of, so in the x direction, I'm going to get 10.3 newtons. So I'm going to update my picture here because I have that information now. And then 12 sine of 30, well, that gets me a really nice 6. So I'm going to update my picture real quick. This is my only x force, so this side is done. So then let's do the sum of the forces in the y. That gets me, I have a 6 up from that Fy vector. So that is a positive 6 newtons. And I have down a negative 6 newtons. So the sum of my forces in the y direction is 0. So my resultant, this time I don't need to do Pythagorean's theorem. It's going to be pretty straightforward. It is simply 10.3 newtons to the right. So I am going to go this way, 10.3 newtons. Now, there is a special case to be had. When your net force equals 0, that means this is a special condition. The forces in this direction are, there's a couple ways to say it. Generally, we could call it balanced, or we could use the word equilibrium, because the forces are equal in that direction. So as a reminder on net force, you're simply adding up all of the forces in the x directions and seeing what your total is. And then you're adding up all the forces in the y directions and seeing what your total is. And if necessary, you then use Pythagorean's theorem to bring them back together. And then use sine, cosine, or tangent theorems in order to find the angle.